Hey, this is Presh Talwalkar. I was reading an article about 10 of the toughest Apple interview questions, and one of the interview questions was a fascinating riddle. There are 100 coins on a table. Each coin has a head side, and on the other side of the coin is a tail side. There are exactly 10 coins which have a head side facing up, and 90 coins have a tail side facing up. You are essentially blindfolded and wearing gloves. That means you cannot see the coins or feel for which side is facing up. Your mission, should you choose to accept it, is to divide the coins into two piles so that both piles have the same number of heads. So how can we solve this riddle? Contrary to popular belief, you are not expected to solve the puzzle instantly in your head. That's not the purpose of the interview. These riddles are designed to be challenging and difficult. The interviewer is trying to see what is your reasoning and thought process, and will you make any progress to solving the puzzle. So let's get started by organizing the information. We have one pile of coins, which we'll call pile A. We'll keep track of the number of heads and tails. Let's say we create another pile B, which will also have coins that show heads and tails. We are given that the initial pile has 10 heads and 90 tails. So when we are blindfolded and we can't see for which sides are showing heads and tails, it will be very difficult to come up with a solution. So let's just break one of the rules and imagine we could see all of the coins. We would know that there are 10 coins that are showing heads. We want to divide this into two piles which have an equal number of heads. So we will divide this in half. So let's take 5 of these heads coins and let's move it over to the other pile. So now pile A will only have 5 heads that are showing, and pile B will have 5 heads and no tails. And we have a solution because both piles are showing 5 heads. In this solution, we did cheat because we were looking at the coins. But you could imagine this might happen by random chance. What would be the probability that we just grabbed 5 coins, they were all heads, and we moved it to the other side? If this was a frequent event, we could just say this is a good enough solution. So let's calculate the probability this happens by random chance. This will be equal to the number of ways that you could choose 5 heads from the 10 heads divided by the number of ways that you could choose 5 coins from 100 coins. We can calculate each of these using a binomial coefficient, and this calculation will work out to a very minuscule probability of 0.000003. So this solution is possible just by random chance, but it's going to be such a minuscule probability that you wouldn't want to rely upon it. So we have to think about a better way to do this. So let's reset back to the beginning where we have 100 coins on the left side, which has 10 heads and 90 tails. Now, instead of trying to target the 5 heads, what if instead we grab tails? Let's say we just grab 10 coins. It's a good chance that all of the coins are tails. So let's say we take these 10 coins and we move it to the other side. So suppose we were lucky and all 10 of these were tails. Well, in that case, the left-hand side would have 10 heads, and if you grabbed all tails, it would have 90 minus 10, which equals 80 tails. The other pile would have 0 heads, and it would have 10 tails. Now in this situation, the number of heads in pile A is equal to the number of tails in pile B. But there's another action we can take. What if we now flipped all the coins in pile B? This would make all of the tails into heads. So once we do that, all 10 of these tails will become heads, and we would exchange these two numbers. So we would end up with 10 heads and 0 tails, and look, the 10 heads will exactly match the number of heads in pile A. So we have a solution. But once again, we were depending on random luck. So let's see the probability this would happen just by chance. we need to calculate the number of ways to choose 10 of the 90 tails divided by the number of ways to choose 10 coins from 100 coins. We use binomial coefficients, and this works out to be approximately 0.33. So just by random chance, about a third of the time, if you grab 10 coins, they're all going to be tails. You move it to the other side and flip them over, and you'll have a solution. And 1 out of 3 times is not that bad, just for random chance. But what if we weren't so lucky? What if instead of grabbing all 10 tails, we instead grab 9 tails and 1 head? How close would we be to a solution? Let's try to work this out. So we go back to the beginning. Pile A starts out with 10 heads. Pile B will start out with 0 of each. So now, let's say that we grab 10 coins and we move it to the other side. So let's suppose that we have moved 1 coin that is showing heads and the other 9 coins are showing tails. So this will be -1 for heads and -9 for tails, and it'll be +1 and +9 in pile B. So the result of this action will be 9 heads and 81 tails on the left side, and it'll be 1 head and 9 tails on the right-hand side. We now need to flip every single coin in pile B. This will turn all the heads into tails and all the tails into heads. So we will end up exchanging these two numbers, so we have 9 heads and 1 tail. Now in this case, we still have 9 and 81 in pile A, and look! The number of heads in pile A exactly matches that in pile B. We have found a solution even though we didn't move all coins that were tails. Even if we were moving 1 coin that had heads, we would still end up that both piles have the same number of heads. But although we have an answer, we have still made an assumption that we were moving 1 coin that was showing heads. What if instead we moved 2 of the coins that were showing heads? Would the solution still work? So let's go through that possibility. Let's imagine we're moving 2 of the coins that are showing heads, so that would mean 8 of the coins are showing tails. Those would be added to pile B. The result is that the first pile would have 8 and 82 for heads and tails, and the other pile would have 2 and 8 for heads and tails. When we flip the two numbers, we end up that the number of heads in pile B is 8 and the number of tails is 2. And this exactly matches the number of heads that is in pile A. So once again, both piles are showing the same number of heads. In fact, this will work for every single possibility. Imagine we were moving 3 coins that were showing heads. We would still end up that both piles have the same number of heads. This is true for 4. It will also be true for 5. And it will be true for every possibility where we are moving a number of heads that's between 0 and 10 inclusive. So it turns out that this solution will always work. We can show this algebraically. Let's say we are moving X heads. If we're moving 10 coins, that means we'll be moving 10 minus X tails. So these coins get moved to pile B. We calculate the result of this operation. We then flip all of the coins in pile B, which will switch the number of heads and tails. We end up, after all this is said and done, that we have 10 minus X heads in pile A and 10 minus X heads in pile B. Therefore, this is a solution, and this procedure will always work. So to summarize once and for all, move any 10 coins from pile A to pile B. Then flip every single coin that's in pile B. The resulting 2 piles will always have the same number of heads. And that's the answer. So if you worked out this clever solution, congratulations. You could be a valuable member of the Apple software team. You will be solving impossible problems that nobody even dreamed were possible. Now, this is an interview question, and Apple has more than just software engineers. So there are other ways that people might answer this question. There are other out-of-the-box solutions, and maybe how you answer will reveal where you could be in Apple. So here's a different way of approaching the problem. Instead of moving 10 coins and flipping them, let's just start out by dividing into 2 piles of 50 coins each. So now there are the same number of coins on both sides. However, you don't know that there are the same number of heads showing face up. But wait a minute. Every coin has a head side and a tail side. The puzzle doesn't state that it has to be the side facing up. We now have 2 piles of coins, and each pile has 50 coins. So there are 50 heads in each pile. Both piles are showing the same number of heads. Ta-da! So if this technicality doesn't impress you, it didn't impress me, because usually we refer to the side of a coin as the side that's face up. Don't worry, there is another clever loophole around this. You could just turn every single coin on its side. There's nothing in the puzzle that prohibits this. So if you thought about the problem this way, then a congratulations is in order. Perhaps you would be a very good candidate for the legal team looking for every single loophole. But there are still other ways to look at this problem. Another person might say that you can melt all the coins. Now there will be 0 heads in either pile. You then might further your answer by saying you should sell the value of the melted metal. You could then use that money to announce a stock buyback. And finally, you give yourself a big bonus for the genius strategy. You may have destroyed the coins, but you made out well for yourself. And if I were the interviewer and someone gave me that answer, I'm not sure whether I would be scared or impressed or both. Maybe you're a good candidate for a C-level position. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.